will be negative or imaginary. Value of y will be imaginary. So curve will not exist beyond origin 0, 0 on the axis of negative side of x-axis. Curve will not exist. So curve will not exist on the negative side of x-axis. On negative side of x-axis. Okay, this is one of the points. So beyond 0, 0 we cannot take because it will be negative. If I put x negative value or -1, -2, etc., y square will be negative. Y square is negative, that means imaginary. So curve will not exist beyond 0, 0 on x-axis. For negative values of x, the curve will not exist. That means the curve is simply, now let me draw that curve. So, and we can just take some points here. This is the origin point we have taken. Okay, and no any point on the curve, only 0, 0 point, and with the curve is meeting. So this is the parabolic equation. X-axis, x dash axis, y-axis, y dash axis, and this is the origin O. Equation of the parabola is standard equation of the standard form of the equation. This is symmetric to the x-axis, passing through the origin. Second point, it will not pass through at other point to x-axis and y-axis. This is the only meeting point here, the axis of x. This is what we have to describe this equation. Let me take now next question. Now 10th question, let me talk about. So what does question number 10 say? Question 10 is of what kind? So up to 9th question we have described. Now these here we have applied the elimination method, the first method we have applied. Okay, up to now. Let me talk about the next question. This is the 10th one. Let me check whether the same method is applied here or other method. Second method. Let me talk about question number 10. So this question number 10 is, okay, question 10 is trace the curve here, x equal to a cos t. Okay, question number 10 here, curve is x equal to a cos t and y is equal to, sorry, this is then the a x equal to, sorry, not complete yet, x equal to a cos t plus 1.2 a log of tan square 1.2t 1.2 of t upon 2, we may say. Okay, this is the value of x, and y is equal to a sin t. Y equal to a sin t. Now in this situation, because it's having lengthy value, so here we cannot apply the first method. Elimination of parameter is not possible here. So it is not so easy a task. Now in this case, what we do, the second method is applied. Let me apply the second method. Solution. Applying the second method. Applying the second method. What is the second method? Finding derivative, differentiating both with respect to the parameter, and then finding d by dx. So differentiating first and second equation. This is first. Let me take the second one. So differentiating first and second with respect to parameter t, we get first is dx upon dt. What is that? This is minus a sine t. Now here it is log of square. We can take it as first 2 can come before, because log m square is equal to twice log m. So before differentiating it, that will take 1.2 common constant. Now this is gdt of, this is twice of log of 10 t by 2. Why? Because this is log 10 square, so 2 power can come before. Now this is simple constant term, so we can do it further. A sine t, this is twice 2 upon 2a constant. Now log 10 t by 2 is to be differentiated. First is 1 upon 10 t by 2. Then 10 t by 2 is differentiated as second square t by 2. Again t by 2 is differentiated, it is 1.2. So t upon 2 is differentiated again by function of a function method. This is the differentiation of log of 10 t by 2. This 2 we have taken before, constant. So what is the final value? A minus a sine t. Here it is a plus sine. I'm sorry, this is plus sign here. Plus. So this is 2, 1.2a, that means a upon 2. This is a upon 2. Here it is second square t. It can be written as 1 upon cos square t by 2 upon sin t by 2 upon cos t by 2. Why? Because second square t is 1 upon cos square t by 2, angle is t by 2, and in the denominator we have tan t by 2. Tan t by 2 can be written as sin t by 2 upon cos t by 2. So 1 cos t by 2 is cancelled out. It is nothing but minus a sin t plus a will be in the numerator, a upon 2 sin t by 2. Twice will come in the denominator. 2 sin t by 2 into cos t by 2. So what do we get? This is sin t only. It is nothing but minus a sin t plus this is a upon sin t. Why? For sin 2t this is, but angle is t by 2, so 2 to cancel out. As or since twice sin theta into cos theta is equal to sin 2 theta. If I write it as 2 sin t by 2 into cos t by 2, angle is t by 2, t by 2. It will be sin 2 into t by 2. 2 to cancel out. That means only sin t. So a upon sin t. So this is the value here. Let me write again. This is minus a sin t plus a upon sin t. If I take LCM sin t, let me take sin t LCM. And a common, can be taken a common. A and a in the numerator both have. It will be 1 minus sin t, because sin multiplied. It will be minus sin square t plus 1. This is 1 minus sin square t. That means cos square t. What do we get? So dx by dt is finally obtained as a into 1 minus sin square t upon sin t. It is nothing but a into cos square t upon sin t. Try to understand. Why? Because since 1 minus cos square theta is equal to sin square theta. Oh, sorry, this is 1 minus sin square. As 1 minus sin square t, since 1 minus sin square theta is equal to cos square theta. This by trigonometric identity we have applied here. This is a into cos square t upon sin t. This is what we have obtained. This is value of dx by dt. So dx upon dt is a cos t. Let me write. We can write it as cot t into cos t. That can also be written, but still let me write in the same. This is value of dx by dt. So this is, let me take third equation. Third equation, this is the first, second, we took them. Now d by dt, what is d by dt here? So d by dt is differentiating the second equation with respect to t, which is nothing but a cos t. Simple, a cos t. Therefore, d by dx is equal to, this implies that d by dx, which is nothing but d by dt divided by dx by dt, dx dt. So dividing d by dt, that means a cos t, by this dx dt. So dx dt is a into cos square t. Sin t will come in the numerator into sin t. So 1 cos t cancelled out, a cancelled out. It is nothing but sin t upon cos t, that means tan t. It is equal to tan into t. D by dx equal to tan t. Alright. So let me write now in fresh. So we get d by dx finally as tan t. So the value of d by dx equal to tan t. For the next process, as I described this, let me take fourth, fifth equation, let me take third and fourth, we took them. Okay, so d by dx equal to tan t. What is the next step? What we do? Now for parameter t, we put different values of parameter t. Or substituting different value of parameter t, we find the Cartesian equations, Cartesian coordinates x and y, and value of dy. Putting or for different values. So this is in an angle only. We will substitute some angles in tan t, or in place of t we will put some angles. Okay, after that we will solve the x and y here. That will give us some value that we put for different values of parameter t. We find the values of variable x, y, and dy dx. Let me frame a table, and after that table, the values of x, y, constants, and the dy dx. Okay, and the parameter t here. T value will be substituted for that. What are the different values? X values, y values, the variables, Cartesian variables, and Cartesian coordinates, I mean, and dy dx, the different values. Let me frame here the table. If I find some values, let me find a table in which we put value of t, then we find x equal to how much, y equal to how much, and what is d by dx. Now we just check from d by dx that what is the value of d by dx in terms of what parameter. I mean, parameter is in form of what, angles or something. Here we can substitute angles only. T in place of t, suppose we put 0, tan 0 is 0, so d by dx is 0. In this way we will find out what is the value of tangents. Okay, the curve will be tangent at that point, what x value of x and y are there. So first we find out coordinates value x and y. At that coordinates x and y, what is the position of the tangent? The slope is what? So slope will be d by dx value. So we will find out d by dx value. So for that, let me put the angles here. Why? Because t is angle of tan here. Tangent can be substituted here only in angles. So let me take some angles. Let me think about some angles here. So those angles can be, what are those angles? Let me talk about. So those angles will be, okay, let me take those angles as minus pi by 2, 0, pi by 2, positive pi by 2. This is minus pi if I take t equal to, because angles are negative, positive both, then minus pi by 2 I will substitute, then 0 equal negative and positive both. So this is pi by 2 positive value, and this is pi. So what are the values of x and y here? X is from this. Now here if I substitute x is a into cos t. Cos t, if I take minus pi here, minus is because cos is even function, it will be even than cos pi. Cos pi is minus 1, it is minus a. But from this log pi is 0 upon something, means log 0, sorry, tan 0, but tan log 0 is infinity. That means this value will be infinity. So x is infinite value. Value of x is positive infinity. X is positive infinity here. At minus pi by 2, if I substitute, then 10 pi by 2, this minus pi by 2, it will be minus 10 pi by 2. 10 pi by 2 is infinity because sin pi by 2 upon cos pi by 2, cos pi by 2 is 0, so 1.0 is 0. So it is negative infinity again. So value at minus pi by 2, sorry, this is what I'm finding out, d by dx, minus infinity, I'm sorry. X will be what? So at minus pi by 2, again this is infinity, then this is 0 here. So, but cos pi by 2 is 0. This value comes out to be, okay, x comes out to be at minus pi by 2, 0. Minus pi by 2 cos will be, this x will be 0 here, because this is 0. This is also 0, this is infinity. If I substitute x t equal to minus pi by 2, tan infinity, but log tan infinity, log infinity is 0. This is 0 here. At 0, this is 1 here, tan 0 is 0, so log 0 is infinity again. So this is value of x we are finding out. So value of x again is minus 0. At 0 it is minus infinity. Okay, so at 0 it is minus infinity. It is minus infinity here. Again pi by 2 is 0. 0. This is also infinity, so 0. So it will be 0. And then it is positive infinity at pi. At pi, it will be again positive infinity, because that is infinity here. These are the values for x. Only this minus infinity, this is the minus infinity, 0, 0, and positive infinity here. Now, y, value of y, simple. T is minus infinity. Sin minus infinity is 0. Okay, it may be, it is minus infinity here or minus 0 here, because sin 0 is 0. It is 0, nothing else. Y is 0 here. No positive, negative, but 0. Because sin pi is 0, sin minus pi is 0, 0. At minus pi by 2, it is sin minus pi by 2, it will be minus a here. Okay, because by a sin pi by 2, but it is minus pi by 2, so it will be minus sin pi by 2. Minus a sin pi by 2, sin pi by 2 is 1, so it is minus a. At 0, it is 0. It is 0. Y is 0 at t equal to 0. Okay. Sin t is, sin 0 is 0. So a into 0 is 0. Y is 0. At pi by 2, it is 1, so it is positive a. Okay. Then at pi, again it is 0. It is 0 here. 0 minus a, 0, a, and 0. Here are the values of y here. 0 minus a, 0, a, 0. Okay. Now d by dx, as I told you, this is now minus infinity, sorry, minus pi. Then minus pi is sin pi upon cos pi. Cos pi is minus 1, but sin pi is 0. So it is tan of minus pi, that means 0 here. It is 0, nothing else. Sin 0, sin pi is 0, it is 0, positive. 0. Then minus pi by 2. This is sin pi by 2 here, but sin pi by 2 is infinity, because sin pi by 2 from cos pi by 2, cos pi by 2 0, so something from 0, 0 is minus infinity here. Minus sign is there, so it is minus infinity. So d by dx at minus pi by 2 is minus infinity. Again, at 0, it is 0 because tan 0 is 0. It is 0 here. Nothing else. It is 0. Then at pi by 2, again infinity, positive infinity. Why? Because sin pi, sin t upon cos t is 0. So 1.0 is sine pi by 2 is 1, but 1.0 is infinity, so it is positive infinity. Then at pi, d by dx is what? Then pi is sine pi upon cos pi. Undoubtedly cos pi is minus 1, but sine pi is 0. So 0 upon minus 1 is 0. It is 0 here. So tan pi is 0. These are the values of d by dx. Now we have to draw the curve for all these values. So we see here at minus pi, the point is infinity 0 at minus pi angle. It is infinity 0. Let me now describe the curve here. And what is the curve then? Let me trace the curve. So what kind of curve it will be? Okay, so these points, sorry, I have just rubbed those points, but let me draw the curve. You can draw that curve. Those points I have to write down again, but I'm sorry, I have just rubbed those points. But this point is at, as I see, at t equal to minus pi, we see, okay, in the first point, the first coordinates are infinity and 0. X is infinity, pi is 0. Okay, so it means when t equal to minus pi, x is infinity. So x-axis is the asymptote here. Okay, so if I take the asymptotes, it means this point we will take here, that those points are a0 or something. Okay, so that point is like this. It is meeting at infinity. X-axis is the asymptote here. X-axis will be asymptote here. Let me further describe this point. X-axis is the asymptote. For infinity 0, we say that at x equal to infinity, y is 0. Similarly, positive 0 is also there, at minus infinity 0. So when x is minus infinity, y is 0. This is at minus infinity 0, and this is infinity 0. Okay, so this is y-axis, y dash axis, x-axis, and x dash axis, origin O. Okay, so the curve is symmetric to the, we obtained that, okay, this curve is symmetric to the x-axis, but x-axis is the asymptote here. So we can see here, from these points, we could just see at all those points pi by 2. Here, let me take pi by 2. This is minus pi by 2. Okay, and okay, so in the same way in the denominator also. And then we took the pi and minus pi. This is minus pi here. This is plus pi here. Positive, or we can take minus pi to that side or plus pi to this side. So these are the points here. Okay, and at this point 0. We can take at this point pi by 2 can be taken to the side or minus pi by 2 that side. So that means check the points here. Okay, so the points are here 0, a. This we talked about 0, a, and this is 0 minus a. At these points are there. So curve is meeting the y-axis at these points 0 and a, and 0 plus a. So 0 plus a and 0 minus a. This we have just taken these points here. We curve 0 minus a and a0. This is a at pi by 2 points. It was a0. Sorry, a0 is at pi by 2, and at minus pi by 2 it was minus a0. Here it is minus pi by 2, and here it is pi by 2. So sorry, this pi by 2 is positive value here. At this point, the tangent is making pi by 2 angle. Okay, this is pi by 2 here. 0 minus a is that point. This is the curve. So x-axis, because this infinity at x tend to infinity by 0. That means x-axis is the symmetric here. And similarly minus pi, it was infinity here. At minus pi, this minus pi was 0 and infinity. Minus infinity and 0. X was minus infinity and 0 was by coordinate. So this is x-axis is the infinity. This is what you call as, this axis is known as, curve is known as, okay, this curve is tractrix, known as tractrix. This curve is tractrix. Is it given there? Tractrix. This curve is known as tractrix. Yeah. This curve is tractrix form. This curve is of tractrix form. Okay, this form is known as tractrix. So this is the shape of the curve. Question number 10th we have done. Okay, so question number 10th here, 11th question let me take. But before that, all these points we have described these, so we have to just find out d by dx in this case, then put the parameter values and then find x and y and dy dx, and then plot those points, okay, with respect to all the points. So what is dy dx? Tangent at that point, what will be the tangent at that point? At this point, tangent is pi by 2, okay, minus pi by 2 is this point, minus pi plus pi or pi and minus pi, okay, any side can be taken, but this is at minus pi here, but infinity and 0 at minus pi. So positive infinity and 0, that is taken. So x-axis is the axis of symmetry, but this is asymptote here, working as an asymptote. So x-axis is the asymptote here. Let me write here x-axis, which I think I've written down already. X-axis is the asymptote. Is the asymptote here. Here x-axis is working as an asymptote because this at x tend to infinity, y is meeting at 0, y is 0, x tend to infinity at that point. Okay, so x-axis is working as an asymptote. Now let me take the 11th question. This is the curve which we have described, the 10th question. So the 10th question is the tractrix. X-axis is the asymptotes, the tractrix here. So minus pi and 0. Okay, at minus pi and 0 minus and plus. Okay, so all these points. Now 11th question let me talk about. Okay, 11th question. So question number 11th. This is tractrix. Question number 10th we have done. Okay, now let me talk about question number 11. 11th question. What did it say? Trace the curve x equal to a cos qt and y equal to a sin qt. A sin qt. This is asteroid. Okay, this equation is, this will form a Cartesian form, but in asteroid form. Okay, so asteroid form is this. If I, okay, this is asteroid form. This kind of question we have already done. Okay, so finding dx dy, again differentiating first and second with respect to x, because we can make it by the same form as asteroid we did, x upon a, then finding out q root and this is squaring, okay, finding 2 by 3 form, and that is also done. But if I do by differentiation, that can also, both, I think both methods can be applied here. This kind of question we did in the in form of here, which is this one, I think. X equal to a, okay, this is this. Second question here, x equal to a sin square t. This is q. Fourth question is there. This is the fourth type. No, that is also asteroid. But 11th question is also asteroid. But this can be done by, let me describe the second method here. How to solve it by second method. Okay, by asteroid method, by differentiation method. So this is a similar type of question we can do by elimination method also. So the asteroid be found. Now in this case, let me find out that what is the second method we can apply here. So applying the second method, let me take solution. The same type of question is this, but by second method we have to apply here. Applying the second method, that is differentiation. So differentiating first and second. This is first equation, this is second equation. Differentiating first and second with respect to t. Let me write here with respect to t, the parameter, we get it will be dx by dt is equal to 3a into cos square t into minus sin t, and d by dt equal to again 3a into sin square t into cos t by function of the function method. So dividing, therefore d by dx is equal to d by dx is equal to how much? This is d by dt divided by dx dt. So dividing this third, this is fourth one by third one. So dividing fourth by third, so we obtain d by dx is equal to, let me write here. So this value, 3a sin square t into cos t divided by minus 3 minus sin here, minus 3a into cos square t into sin t. Okay, so this is 3 cancel out, a cancel out, this is negative minus sin, and one sin cancel out, one cos cancel out. It is sin t upon cos t, that means minus 10t. The value is sin t upon cos t. This is nothing but minus sin t, 10t, sorry. d by dx is here. d by dx here is minus 10t. Okay, this is this. Let me take fifth equation. Now putting different values for t. Again, angles we will substitute here. Let me find what is the curve will be here. So let me find a table finding the different, or putting different values for t. Putting different values of t, the parameter, and finding the values of x, y, and d by dx. Let me frame the table. This table, in this table we will find out different values for the parametric values. Okay. Here the parametric values are, let me